This module focuses on the last means comparison that we're going to cover. Specifically, it's called an ANCOVA, an analysis of covariance. For this module, you're going to need output 12, the test that's actually going to be run, and output 12, the outputs that will emerge from that test. And then you will need to open a database in your K-12 data called Parent 1 Edited. Parent 1 Edited. An ANCOVA is a very useful test in my mind because it levels the playing field when you're comparing a dependent variable for two different groups that are very different. The classic example is in the case of schools. If we said we're going to compare the test scores of two different schools, and one of those schools was in a very affluent area and the other one was in a very low income area, and we found differences in the test scores, that wouldn't necessarily be differences in what the schools are actually doing. It may just be differences in the two groups. In other words, the kids taking the test. So I would never run a simple t-test, an independent sample t-test comparing a very affluent school to a very poor one. While poverty isn't a causal variable, we know that income level correlates with test scores. And that's why we need to use it as a covariate when we're comparing schools that serve very different students. Think of covariate, think of to-vary. A covariate is a variable that differs between your two groups, that's one part, and then it also affects your dependent variable. So what you want to do with a covariate is you're going to say, I want to know if there's differences in these two schools' test scores after I control for differences in the students. So my covariates might be students with disabilities, English learners, low-income students, mobility rates, and so forth. And it can make a huge difference in the conclusions that you draw. In this particular case, I want you to look at output 12. I'm going to read the sample question to you. Is there a difference in teacher communication with parents between different school types after controlling for parent income? So, is there a difference? That tells me, again, I'm in a causal comparative research design. I ask myself, how many dependent variables do I have? I have one, teacher communication with parents. I ask parents how often teachers communicate with them about how well their child's doing in school, discipline problems, volunteering at the school, how they can help them with homework, and so forth. And I take a mean of all those items. In this case, in this database, I have two different school types, magnet and non-magnet schools. So I've got parents who have kids in those two different school types. If I wanted to run an independent sample t-test, I would just say, is there a difference in teacher communication with parents between magnet and non-magnet schools? Stop. That's an independent sample t-test, and frankly, it could be an ANCOVA if I wanted it to be. But I added that keyword controlling for parent income. So I suspect there's research that says affluent parents are more likely to exercise school choice for lots of reasons. And this is one concern that traditional schools often have with school choice. So if we're right and more affluent families are in magnet schools, and I want to compare teacher communication with parents, the finding may not be differences due to differences between the schools. It may be differences between the parents who have children in the schools. So I'm going to level the playing field, and I'm going to essentially say, I'm going to get the variance out of parent-teacher communication that's associated with parent income, so that any difference is really due to the differences in the two school types. Okay, so how do we run that? We're going to go up to Analyze. Again, we're now into a higher level. We're going to go past the simple means comparisons, and we're going to go to General Linear Model. And I'm I'm going to move over to univariate. Una meaning I have one dependent variable, in this case, teacher-parent communication. So I open that up, and I've already filled this in. Teacher communication is down about 2/3 of the way, teacher communication, and I'm going to move that over to the dependent variable. My fixed factor is just my two groups. It's my school, my independent groups if you want. I'm a parent with a kid in a magnet, or I'm a parent and kid in non-magnet school. So that's up near the top, third variable down, type, move that over. The next thing I'm going to do is I'm going to find my covariate, the things that I'm going to control for. I could control for as many things as I want. In the case of test scores, I want to control for student attendance. I want to control for student income level. I want to control for disability, English proficiency. But in this case, all I said was I want to control about 2/3 of the way down for a parent's approximate level of income. The next thing that I'm going to do is one box down to covariate, controlling for parent income. Is there a difference in teacher communication with parents between magnet and non-magnet schools, controlling for parent income level? Next, I move over to options, and I want to see the means for the school types. I want to click descriptive statistics, and I want to click homogeneity test, that Levine's test. I click OK and run the test, and here's an output of an ANCOVA. So my first table is basically saying what are my two groups that I'm comparing the dependent variable between. I've got magnet parents and non-magnet parents, roughly over 600 of both types. The mean teacher communication with parent level in magnet schools is 2.33. In non-magnet schools, it's 2.46. It is critical to note, if I ran a t-test, an independent sample t-test, these would be the means I would be comparing. However, I'm not comparing them without leveling the playing field for differences in parent income level between my two groups. So these are not the means that are actually being compared. The next table tells me, do I have equality of variance or homogeneity of variance between my two groups? The null is I do. I don't reject that, so I can assume equal variance because my significance is not less than 0.05. In other words, move forward with the test. It's a valid one. This is like the overall test. There are two key numbers in this. Only two numbers that you need to focus on are the first covariate, which is Q38. That's just the label for parent income. I scroll over and I look at the significance, and it's not less than 0.05. So it is not a significant covariate. I didn't really need to control for it, but in your written descriptions you would say parent income is not a significant covariate. Type, remember, is non-magnet parents and magnet parents. So I scroll over and I see a significance value of 0.025. In other words, there are differences in teacher communication with parents between magnet and non-magnet schools after controlling for differences in parent income. So everything below the word intercept will be your covariates until you get to your main groups. So I only have one covariate. All I need to look at here is Q38 and type. Q38, parent income, is not a significant difference, but my conclusion would be there are differences in parent-teacher communication between magnet and non-magnet schools after controlling for parent income level. Earlier, I said we're not comparing those means at the top. Those aren't adjusted. The means that are actually getting compared in this test are adjusted means. You'll see an A after each mean exponentially. That A stands for adjusted. So the adjusted magnet school parent-teacher communication mean is 2.33. Adjusted non-magnet parent-teacher communication mean is 2.45. And those are statistically different. They are adjusted for your covariate, in this case, a single covariate. So I would conclude non-magnet schools have greater parent-teacher communication than magnet schools after controlling for differences in parent education. So a key finding here is my parent income level didn't matter much. It wasn't even significant covariate. So if we look at the adjusted mean and just remember it, it's 2.33 roughly, 2.336 for magnet schools. So I'm going to scroll up to the non-adjusted mean, and it was also 2.33. So the fact that the non-adjusted mean and the adjusted means are so close tells me that the covariate or covariates selected in this case weren't very important. If I was looking at something like test scores and I covaried income level, disability, and English proficiency, a mean test percentage correct on, say, a reading test could have been 60% out of 100% non-adjusted, but then when I adjust for those factors, it might look like 85%. So I just didn't choose a very good covariate in this model. It's not something I needed to level the playing field for. I did have a logic though. Higher income parents, we know, choose magnet schools, so they differ between the two groups. Your average parent has a higher income level in magnet schools. I just thought it would affect teacher communication with parents, and it didn't much. And the reason I would think that is, if you have a car, you're more likely to be able to get to school to communicate more frequently. You may be more likely to have a phone. If you're not an English proficient parent, it's difficult for schools to communicate with you. So I had a logic for it, but in practice it just didn't matter that much. That's an ANCOVA. We'll run another example in just a second.